So let's talk about logistic regression. While linear regression, the topic of the last module, linear regression attempts to estimate some generic relationship between an input X and an output Y. Logistic regression attempts to estimate the behavior of a system as a binary or multi-class classifier. And we'll come back to those topics in a few minutes. We have discussed them in previous modules, however. For example, let's say we observe the frequency with which Michael Jordan makes a three-pointer at various locations on the basketball court. Logistic regression may learn from these observations, from that information, and estimate the probability that Michael Jordan makes any future three-pointers based on the location where he shoots. We may summarize logistic regression, or the process of logistic regression, in 3 steps. First, we need to define something called a logit. We'll explain again later what that means, but essentially it's a linear combination of parameters and states. We refer to it as Z. We then apply a logistic function to that logit, Z. And then the third step, which is probably the most complex, is to minimize an objective function that's based on the logistic function from step number 2, with the objective of yielding an optimal or a set of optimal model parameters. Now, step number 3 is easier said than done, and we'll see that for this, we'll be using MATLAB, but there's a lot of complications involved with that. Ideally, these optimal parameters, which we call theta sub OPT, same notation from the previous module, these optimal parameters allow the tuned logistic model to accept inputs and accurately estimate the probability that a corresponding output Y falls within one of multiple categories or classifications. If we go back to the Michael Jordan example, it accepts a location on the court and tells us whether this should be a shot that he makes, being one classification, or misses, being the other classification. We also, in this module, consider an example, pretty simple one, of an animal, a small animal, and its observed behavior to approach a food source or not, based on certain environmental factors, the color of what it's approaching, its size, whether there's movement observed around it, and we're going to apply a logistic regression both by hand as well as in MATLAB in order to try to mimic that behavior, that ideal behavior.